Hello everyone, welcome to the GATE NPTEL lecture course. Today we are going to solve question number 32 from GATE 2018 examination. So in this question it is given that a long straight wire having a radius A and resistance per unit length R carries a current I. The magnitude and direction of pointing vector on the surface of the wire is. So basically you have to calculate the pointing vector here, which is given by S vector equals to 1 by mu naught E cross B. So you have to know what is the electric field onto this surface and you have to find what is the magnetic field on this surface. So the magnetic field due to a straight wire is given by mu naught I upon 2 pi R in the phi cap direction if this current direction is the Z cap. So the magnetic field at this surface when small r become capital A here is given by mu naught I upon 2 pi in the phi cap direction. So this is my magnetic field. Now to calculate the electric field, we can use the Faraday's law. Faraday's law says that the direction of the electric field that is induced due to the flow of this current in the conductor is in the same direction as the current. So the direction of electric field is in the z cap direction. So electric field is given by minus del V by del R in the z cap direction, where V is the potential across these two surfaces. So here, if the current is flowing, so that means this is the negative direction and this is the positive direction. So we can take it as like potential divided by the length. Here is the length element in the z cap direction. I'm just talking about the magnitude here. So the mode of E is given by potential upon length. So we already know that the potential V is given by I into R. That is from Ohm's law. So I is the current, R is the resistance, and the potential, and it is given to us that resistance R per unit length is the small r. It is given in the question itself that the resistance per unit length is a small r. So potential per unit length, which is I R by L, is equals to I small into R. So the magnitude of electric field is I R, or the electric field is I R in the z cap direction. So the S vector, which is 1 by mu naught E vector cross B vector, is equals to 1 by mu naught I R in the z cap direction cross mu naught I upon 2 pi A in the phi cap direction, which is equals to this mu naught will cancel out. So I square R by 2 pi A z cap cross phi cap. So in cylindrical polar coordinate system, z cap cross phi cap will become minus r cap. So I square r upon 2 pi a minus r cap. So r cap is the direction which is away from the origin. So if this is your cylindrical polar coordinate system with z cap, and this is your x, this is your y, such that phi cap direction is this, then the r cap is this away from the origin. So this is the r cap. Now here it is a negative r cap direction. That means it is opposite side of that. So basically, if you are taking as outward direction, so our pointing vector is coming towards the inward direction. So the direction is perpendicular to the axis. Yes, the axis of the wire is in the z cap. R cap is perpendicular to that, and it is pointing inwards, and the magnitude is I square R by 2 pi A. So the A is the correct option here. Okay, thank you.